Welcome friends to the lecture of marketing research and analysis. So, in the last class we were talking about a new technique called cluster analysis. So, we understood that cluster analysis is a technique very similar to factor analysis, which is also called an interdependence technique. It is a subjective measure where we are trying to classify objects or create groups or clusters which have lot of similarity within themselves, right. And our intention is to create such clusters so that within the clusters there is a lot of homogeneity, but with between two clusters there is a lot of heterogeneity. That means, two clusters are as far from each other as possible, but the data points within the clusters are very much similar or close to each other. That is the objective of the study. And where it is used? It is used for in areas like climate change, even biology, even botany, in genetics, and largely in also marketing, right. So, our interest is mostly into marketing because we want to segment the market. When we want to segment the market, how do you segment the market? When you have to for that you have to understand the consumers buying behavior and patterns, right. So, to do that cluster analysis is very helpful. Another area which is nowadays becoming where cluster analysis is also being largely used is the in the political system, right. During elections and all, where people want to when leaders are giving the speech, they try to create a speech according to the behavior of a particular cluster. So, suppose some cluster is a very traditional for example, some leader wants to give a speech in a place where the people are mostly very modern and fashion oriented. So, he would talk more about such kind of issues, right. Suppose somebody is a very sensitive place and people are more open to they are open to relationships and all. So, they talk more about such kind of rules and regulations. In some places people might be very orthodox and very orthodox people. So, there they would like to talk more about holding to the basics and fundamentals and all. So, it helps leaders also to create a different kind of speeches for themselves and accordingly cater to the audience. Okay. So, cluster analysis is being largely utilized in every sphere nowadays, right. And we said that it uses instead of the correlation measure, it uses the distance measure, right. And we learned that in the last lecture that basically there are two types of cluster analysis. One is the hierarchical cluster analysis and the other is the non-hierarchical cluster analysis. The hierarchical cluster analysis, the objective of the hierarchical cluster analysis is to identify the clusters. Basically it helps you to identify the clusters, and the non-hierarchical cluster analysis helps you to identify the characteristics of the cluster. For example, hierarchical only said to you how many clusters can be formed, that how many is explained through the hierarchical clustering, and what is the characteristics of the cluster is explained in the non-hierarchical or the k-means clustering, we say, right. So, let us see what how it is done. So, hierarchical cluster analysis, as I was just saying, non-hierarchical and combination of both. So, sometimes many of the times it is better, it is advised that we use a combination of the hierarchical cluster and the non-hierarchical cluster. So, that here the number of groups or number of clusters are decided, and here the characteristics of the clusters are decided, are observed, in fact not decided, are observed, of the cluster is observed, right. And then the researcher or the company, the marketer can decide which cluster to cater to, right. So, let us see the hierarchical cluster analysis. Here the stepwise procedure attempts to identify relatively homogeneous groups of cases. You remember this is basically the cluster analysis is done on cases, right, as factor analysis is done on variables, it is done on cases, but that means the respondents cases based on selected characteristics using an algorithm either agglomerative or divisive. Agglomerative means combination, combining, divisive means breaking it up, resulting to a construction of a hierarchy or tree like structure depicting the formation of clusters. It is preferred when sample size is moderate, under 300 to 400 and not exceeding 1000. So, hierarchical clustering is preferable when you have a moderate sample size. Okay. So, as I was saying, two methods, agglomerative and divisive. It begins with each object or observation in a separate clusters in each subsequent step the two clusters that are most similar are combined to build a new cluster, and this process goes on and on and on till you have a single cluster, right, from n clusters to one cluster. Divisive, it begins with all objects in a single cluster, right, which is then divided at each step into two additional clusters that contain the most dissimilar objects. So, single cluster is divided into two clusters, then one of these clusters is split for a total of 3 clusters. This continues until all observations are in a single member clusters from one cluster to n sub clusters. That is the opposite way, right. So, this is how it looks. So, this is the divisive method. If you go this side, right, from 6 to 5, 4, 3, 2, 1, right, and if you go this way, that means this side, right. So, it is the agglomerative way. Okay. So, first there are different types of methods when you talk about the agglomerative technique. So, the 3 most popular agglomerative algorithms are linkage method, which has, I will tell you what is that, centroid method and variance method, right. So, when you use any software, for example SPS or something, it will ask you which approach you want to use. So, linkage method, a single linkage method, a complete linkage method and average linkage. What is that? Let us see, and then we will look at each one of them. It is also called the nearest neighbor method, defines similarity between clusters as the shortest distance from any object in one cluster to any object in the other. For example, this is one cluster and this is another cluster. Now, there are several data points. You see, this is a distance, this is a distance, this is a distance, right. Similarly, from here, if you, this is 1, this is 1, this is 1, similarly this is 1, this is 1, this is 1, but which is the closest or the nearest point? This one, right. So, this one is the closest. So, this one is the closest, right, the most bold looking one. So, now what it does is it tries to add the clusters on basis of the nearest point, taking that nearest point, shortest points. Okay. Complete linkage is just the opposite. It takes the data on basis of the farthest neighbor. So, the farthest. Okay. So, the oppositional approach is to single linkage assumes that the distance between two clusters is based on the maximum distance between the two members in the two clusters. Third is the average. Now, what is the average? It identifies all the different points and adds them and takes the average distance between all pairs of the two cluster members. So, that is why if you have large data points, hierarchical clustering becomes little difficult, right, because so many combinations will come, so many calculations have to be done, right. Then the next method is after linkage, we have the centroid method, a method of clustering, hierarchical clustering, in which clusters are generated so as to maximize the distance between the centers or centroid of clusters. What are these centroids? Cluster centroids are nothing but the mean values of the observation on the variables of the cluster. So, we take the mean value, the distance between two clusters equals the distance between the two centroids. So, it takes the mean value and finds a centroid, right, in this, for this cluster this is the centroid or the mean point, right, and then it takes the distance between these two points, right. The third method is the variance method, right. What is this method doing? In this method, the clusters are generated to minimize the within cluster variance. So, you know about within cluster variance means, so within the cluster you take all the distances, right, and you measure the variance, right, and then find out the minimum variance, right. So, here the method used is called the Wards method. In this method, the similarity used to join clusters is calculated as the sum of squares between the two clusters summed over all the variables, right. This method has the tendency to result in clusters of approximately equal size due to its minimization of the within, and the problem again, the Wards method makes it very complicated sometimes, because the calculation within the software for the software becomes very complicated because large number of calculations are to be done. So, that is the only otherwise for you and me it does not matter, because we only check the output, but for the computer it takes lot of exercise. Okay. So, let us do one. This is the pros and cons of the hierarchical clustering. For example, it is simple and yet portrays the clustering solutions, speed, advantage of generating an entire set of clustering solutions in an efficient manner, right. But what is the problem? Difficulty in analyzing large samples, that is what I was just saying, and the results are more susceptible to outliers. If there are outliers, then it will have a problem, right. So, let us take one case. This is a case which I have brought. So, this is a there are different names of different childrens, right. Their age is given, memory span is given, IQ is given, reading ability is given, right. This I think we have also used during regression, the same data set we have used. So, now suppose I want to do a hierarchical clustering. So, I want to see how many clusters can be formed out of it, right, first question. So, to do that, first of all what you do is, see I will explain, go to classify and you see hierarchical clustering here. So, when you go to hierarchical clustering, take the data points that you are interested in, the variables, right. Okay. Now what do you want? Now go to statistics. Here the agglomeration schedule is by default there, so no issues, right. Continue. I am never interested in looking at the dendrogram because I can find it through the agglomeration schedule. So, I do not use the dendrogram generally, right. So, you can use that, but then it looks very odd sometimes, very complicated, and I do not feel it is just is required even, right. So, method. So, what is the method you would use? So, there are different methods. So, generally the one of the best methods is the Watts method, and how do you want to measure the distance? The squared Euclidean distance, this is by default. Yes, this is now important. You see, now if suppose do you want to standardize, it is giving an option. You need to standardize when your data are measured in different kinds of scales. If they are not measured in different kind of scales, you need not have any problem, right. But if you have measured, if you have the suppose some in categorical, some in kind of a continuous or such kind of scale issues are there, then you will have to just standardize. You do not have to do anything, you just have to go for these two options, either Z score or range between -1 to +1, right. So, if you give any of them, they will it will be standardized, and then the scale issues are automatically gone, okay. So, I am not doing it here, right. I will show you if you want to do in another case maybe, right. So, do you want to save the value? Now, do you want to save it? Well, at the moment no, because it is just I want to find the number of clusters. So, nothing here. Now, okay. Now, let us see. Now, if you look at it, so see this data is a very small data, just for an class purpose I have brought it. Now, look at the agglomeration schedule. Now, how many clusters are to be formed? You can get it from here. Now, for example, look at the last value, go from backwards, 794.185, the coefficient value, right. Then the next one is 249. So, there is a significant difference in the value, there is a great fall, or you can say if you come from this way, great jump. Here also there is a significant difference, here also to some extent here. So, you up to that point you go till you feel ki there is a serious or a big difference between the two values, right. Suppose, but remember one thing, if you create too many clusters, it is not very good. Why? Because then the characteristics of the clusters will be very thin and there will be very little difference between them, sometimes very much possible. If you create only one cluster, then there is no point, because the cluster if it is only one cluster, then there is no point of doing a cluster analysis. So, you should be reasonable enough to understand how many clusters are to be formed. For example, in this case I will take 1, 2, 3 and 4, let us say 4 clusters, and see whether there is any significant difference. So, this part of understanding and identifying how many clusters are to be done is done through this agglomeration schedule. So, you just have to look at these values and see till what point there is a substantial change in the values, and when you find the difference is now not much, then you stop there. That is what it does, right. In the non-hierarchical cluster analysis, so after you have identified the number of clusters, the next part, what it does is, the non-hierarchical clustering does not involve the tree like construction process. Instead, they assign objects into clusters once the number of clusters is specified. So, you have to specify here during the non-hierarchical, you have to specify the number of seed points we say, or the number of clusters, right. The number of the non-hierarchical clustering method are basically there are 3 types basically, but we are more bothered about this k-means method. So, if you go to SPSS or anywhere, you will find that instead of non-hierarchical clustering, there is no name called non-hierarchical clustering, only you find a k-means, because it is almost all the time that the k-means clustering represents the non-hierarchical method, right. So, sequential there are 3 methods as you saw here, these 3, right. So, what are they? It starts by selecting one cluster, the sequential method, one cluster seed and includes all objects within a pre-specified distance, because the whole measure is distance. The disadvantage is that when an observation is assigned to cluster, one cluster, that means is assigned to one cluster, it cannot be assigned to another cluster even if it is more similar. So, that is one problem with the sequential. Parallel threshold method is a non-hierarchical method that specifies several cluster centers at one point, right, more like a divisive method. All objects that are within a pre-specified threshold distance from the center are grouped. Okay. So, these are the 3, and the optimizing procedures, which is the k-means, it differs from the 2 in that objects can later be reassigned to clusters to optimize an overall criterion such as average within cluster distance. So, average within cluster distance is what we are talking about, the Watts method. So, our objective is to reduce this minimum within distance, right, within cluster distance. So, let us say okay, this is the sum of the pros and cons, you can check it later on. We will use a combined approach. Now, let us go back to the data set. Now, once we had done it, right, we had suppose 3 or 4 clusters. Now, we will go back to the k-means cluster. Now, again we take all the data, the variables to this side, right. Now, I am interested to see whether this is okay, save. Do you want to save anything? You want to save which the particular respondent comes into which cluster membership, you can do that. You can even check the distance from the cluster center, right, continue, and options, initial cluster center and cluster information, continue, and number of clusters, here I would like to make a change. So, for example, I have gone with 4 clusters, you may make it 3 or you may make it 5, it is, there is no binding, it is a researcher's own logic that has to be used. Okay. Okay. Now, we have run it, you see, now we said 4 clusters and the 4 clusters have come, this is the initial cluster center, and then it tells you the cluster membership. Okay. Okay. So, each cluster case you see 1 to 20 respondents were there. Now, first respondent is in cluster 1, second cluster 1, third cluster 3, 4 cluster 4 on basis of certain behavioral traits. Let us see what is that. So, go to the final cluster centers. So, go to the final cluster centers. So, there are 4 clusters, cluster 1, cluster 2, cluster 3, cluster 4. So, what is the behavior of cluster 1? Let us see. Cluster 1 is somebody whose mean age is 5.9, short term memory span is 4.88, IQ is 101.2, reading ability is 6.58, right. Cluster 2 has got a higher age mean from cluster 1, but memory span is almost equal, right. IQ is less, right, than cluster 1, reading ability is slightly higher. Cluster 3, age is quite less, the mean of the age is quite less, short term memory span is 4.33, again it is quite less, right. IQ is very high, right, and reading ability is poor, because obviously we can connect that it is a young child, because it is a child, the age group is also less, the age minimum age is less. So, that is why this might be reading ability might be less also. Fourth is that fourth cluster is 6.06, again not very high, not very low, it is in between, and look at the memory span, very poor, right, in comparison. IQ is 90, the lowest, and reading ability is again also in the lesser one, right, lesser side. Now, once a company or a researcher identifies these clusters, the behavior of the clusters is also known to you. Now, suppose let us say had it been a case of a marketer, and the marketer knows what is the age group of the people who are using its products, what is their memory span, what is their IQ level, what is their reading ability, suppose a bookseller for example. Now, he can say, well, I want to target only, see, you cannot target all the groups, right, because that is why segmentation is done, so that you can choose your target segment. Now, out of this 4 maybe I will choose only 1 or 2 or maybe 3 or whatever it is. So, let us say he wants to select 2 clusters out of it. So, which 2 clusters will he select? The question is, you can see from the distance between the final cluster centers. Now, cluster 1 and cluster 2 5.25, 1 and 3 5.2, 1 and 4 11. So, 1 and 4 are really far off from each other, that means there is a very huge distance between the 2 clusters. Cluster 1 2 1 3 1 4. So, 2 3, now 2 and let us say 3 10.4, again it is far off, 10 and 2 and 4 5, right. Cluster 3 and cluster 4 very far off. So, we can see here that cluster 2 and cluster 4 are seems to be the one which is very close, right. My sample size is very less, but when you do, you can use it on a larger sample size. So, by understanding this, the marketer can understand that cluster 2 and cluster 4 have some similarity, right, some similarity, and they can target maybe that particular cluster. So, this is only to make you understand, to realize how it works, you can how do you use it, right. But then you can use your logic and see what is to be done and what not is to be done, right. So, this is how a cluster analysis works, right. So, you combined approach is what I just now did. First, through the hierarchical clustering you find select the number of clusters and serve as initial cluster seeds for the non-hierarchical, right. And the non-hierarchical cluster then clusters all observations using the seed points to provide more accurate cluster memberships. Now, I wanted to show you something here. Let us go to the data set. Now, you see everything is given to you now, which this particular respondent falls into which cluster, and what is it the cluster distance, the distance the distance, right. Now, if you will see, the higher the distance, that means farther, and which member, suppose you want to know this guy Ronald, in which cluster does it fall? Now 4. Who are the other? Suppose you are interested in cluster 2 and 4 as a marketer. So, 2 and 4, let us see who are the people. Now, Louise, Ronald, Gertrude, Beatrice, Queenie, Thomas, Morris and Noel. So, these are the people who are a part of your target segment, right. So, you do not want to invest your resources or waste your resources for the cluster 1 and cluster 3 and cluster maybe 2. I am only interested for cluster 4, let us say, for the time being, just to understand it, right. So, then my focus, all my resources will be diverted towards cluster 4. So, that is how it helps the marketer a lot, okay. And you obviously you can see from here, if the same logic applies to a as I was giving a political example. Now, suppose this is I know that cluster 1 is a very suppose I am just saying is a very open minded person, cluster 3 is a very religious person. So, when a politician goes to these 2 cities, cluster 1 or city 1 is a very open minded city, people are like very modern and modern thinking approach. Cluster 3 is a very traditional religious kind of people. So, the speech of the politician will differ in both these cities. Okay. So, that is why it is very important to understand what kind of cluster does the city fall to, or the person fall to, or the product fall to. So, this is very important to understand. Okay. So, this is what we have done. So, I have the steps are all mentioned over here. So, now it will help you to understand how to proceed with the cluster analysis, right. So, once you can do this. So, these steps I have already done it, and this is for your reference only, right, how you do, and after you do, then you can finally write your cluster analysis report, that interpretation. So, for example, you may write that we did a cluster analysis, and we first conducted a hierarchical clustering analysis, and we found 4 clusters, 3 or 4 clusters, and then after that we did a k-means clustering, and we found the behavior of the clusters. There are 4 clusters, for example, the cluster 1, and write down the behavior of the traits of the cluster entire, right. So, the age group was this, the memory span was this, and this and this, and similarly cluster 2, cluster 3, cluster 4, and then you may give your opinion which even you should do one thing, please remember that kindly give the names of the clusters. For example, cluster 1. Now, according to the behavior of the cluster, you can give a name to that particular cluster, right, maybe young and very intelligent students, right. Second, impulsive and very logical, not impulsive, logical does not go, impulsive but very sharp IQ, right. So, you can what you can do is you can give a name to those clusters. So, that will be very helpful for others to understand what is the basically the trait of this particular cluster, right. So, this is how you do a cluster analysis and you interpret it, right. I think this would be extremely helpful for you in the future, and if you use it well, you can really make good publications out of it. So, wish you all the luck. Thank you so much.